So hello guys. Uh, so today we will see some more points related to the probability. If you remember in the last class we have seen what is probability, why to study probability, what is the contribution, and we have seen some more points related to probability like what is event, what is the meaning of, what is theoretical probability, what is experimental probability. So we have seen multiple points, and then we have seen some of the questions also. So today we will start a new point. In the probability we have to study something called elementary event. Okay, so what is elementary event? Elementary event is, see, if you remember, then I have given one example, right? We have solved one example. The example was head and tail example. Example was, the question what we have solved is, we have a coin. The same first example we have solved, right? We have a coin, and when I am tossing the coin, so what is the probability that the head will come? So in that question, the question was like, I have a coin, right? I have a coin, I am tossing this coin, then what is the probability of probability of getting head, and what is the probability of getting tail? So you do not have to write this question because it is already there in your book. Okay, so I just wanted to explain what is the meaning of elementary event, so I am taking this example. So if you remember, then we have solved in the earlier class the answer of probability of being head equals to 1 by 2, because the number of sample space we have found equals to h comma t, right? The number of sample space for this tossing of a coin was h comma t, and probability of coming head means number of event we have found equals to 1, right? So if you can see, when the question is what is the probability of getting head, the number of event equals to only 1, because only one is here, only one head is here. And if you say probability of getting tail equals to 1 by 2. Why? Because only one tail is there. So in any event, if the number of event if the number of probable event is 1, is called elementary event. In any event, the number of probable event, okay, number of favorable outcomes, in terms of your definition, the number of favorable outcomes is 1, then it is called as elementary event. Okay, so you can say that elementary event is, this is getting head is an elementary event, getting tail is an elementary event. Why? Because here is only one probability of favorable outcomes, only one number of count for the favorable outcomes, right? So this is called elementary event. If you want to write the definition of the elementary event, before definition I will just give one more example to let you clear this thing. Okay, so I am giving another example. Another example is, if you remember, I have solved some question on the like Kritika is pulling some balls from the bag. You remember this question? So question where in the bag there were 3 balls. One was red ball, one was blue ball, one was green ball. Okay, and Kritika is pulling one ball. Kritika is taking one ball from the bag. What is the probability that the ball will be red, right? So probability we have found, like in number of sample space equals to what? 3, 1, 2, 3. Number of event for red equals to 1. So probability of getting a red equals to 1 by 3. For the green, we have found probability of getting a green equals to 1 by 3. Probability of blue equals to 1 by 3. So why this came as 1 by 3, 1 by 3, 1 by 3? You remember in the last, you can go and watch the last video if you are not clear on this concept. Okay, so you can see Number of favorable outcomes is 1, number of favorable outcomes is 1, number of favorable outcomes is 1 for each of the event. So in any of the event, if the number of favorable outcomes is 1, is called as elementary event. It is very clear? Fine. So we'll see another concept now. Not another concept, I will just give one example, then you can only say that whether it is an elementary event or not. So another example is, okay, fine. Fine. Another example is your question, in your book, the question number 3 is there, right? Question number 3. Question number 3 is saying, suppose we throw a die once. Suppose we are throwing a die once. So in a die, how many numbers are there? 1, 2, 3, 4, 5, 6, right? So dice means chakri, Ludo chakri, right? So how many numbers you can see in the Ludo chakri? Whether 1, 2, 3, 4, 5, 6, right? So the question is, suppose we are throwing a dice once, what is the probability of getting a number greater than 4? See the question. In the question, the first part is what is the probability of getting a number greater than 4? Probability of getting number greater than 4. If I will go by this point, getting number, so first of all, how to solve the probability question? First step is answer number of sample space equals to what? Number of sample space equals to total number of outcomes. Total number of outcomes on one die is 1, 2, 3, 4, 5, 6. Correct? Now next is probability of getting number greater than 4. You just say me, in 1, 2, 3, 4, 5, 6, number greater than 4 is how much? Greater than 4 means it is a 5 or it is a 6. So how many counts are there? 2. So you can say that number of probable event equals to 2. Any doubt? No, because getting number greater than 4, it is greater than 4. 4 से बड़ा कौन है? 5 and 6. So if I will say what is the favorable outcomes for this question? Favorable outcomes is 2. That is number of event equals to 2 and number of sample space equals to 6. So if I will find the probability of getting probability of event equals to number of event by sample space. Event is 2, sample space is 6. You can write it at 1 by 3, but do not write it. Just think, because I am living here, just to think something else. Okay, I will take another question. In the same question, B part is there. Second part is, what is the probability of getting a number less than or equals to 4? Probability of getting number less than or equals to 4. See the question, less than or equals to 4. Again, how to solve this question? First part, number of sample space equals to what? It is the same question, right? So number of sample space equals to 1, 2, 3, 4, 5, 6. Number of event equals to what? Event, what we have to find here? We have to find getting number less than equals to 4. Means 4 से छोटा या 4 के बराबर. In this one, in whole this part, 4 से छोटा और 4 के बराबर. Smaller than 4 or equals to 4. How much is there? This is smaller than 4. This is smaller than 4. This is smaller than 4. This is not smaller than 4 but equals to 4. And here we have to consider equals to also. So what I will do, I will just delete this one. How many number of probable event is here? How many? 1, 2, 3, 4. So number less than equals to 4 is how much? 4. So I will put number of event equals to 4. So probability of event equals to 4 by 6. Now just think little bit. Here probable outcome value is how much? 2. Here probable outcome value is how much? 4. It is 2 and it is 4. So in the elementary event, we have seen that all the probable outcome value was 1, right? We have seen that one. We have seen something like getting head equals to 1 by 2, getting tail equals to 1 by 2. We have seen something like that. But here the probable event is 2. Here probable event is 4. So in any event, if the probable outcomes is greater than 1, is called not an elementary event. So these two event is, what is this? This is not an elementary event. Correct? So you understood the concept. Elementary event means if the favorable possible outcomes is 1, here 2 it is. So if the favorable outcomes is 1, then that event is called elementary event. If the favorable outcomes is greater than 1, that is 2, 4 or anything greater than 1, is called not an elementary event. Clear? Fine. So that is what you can write it on. This is the first one was the elementary event, second one was not an elementary event. This is not an elementary event. Okay, so these questions can be asked in your exam in a 1 mark question. What is the meaning of elementary event? What is the meaning of non-elementary event or not an elementary event? So you can write the definition like, if in any event, if the favorable outcomes is 1, number of favorable outcomes is 1, is called elementary event. If the number of favorable outcomes is greater than 1, is called not an elementary event. Fine. Now see, today we'll have so many interesting topics. So we'll just see one by one. Okay. Now again we'll go to the first example, that coin example, because there some concept is present, right? So what was that coin example? Coin example was when we are tossing a coin. What is the probability of head and what is the probability of tail? See, this question it is there in your book, so do not worry about the writing I am not able to understand. It is in your book. You can write the question from book, but understand the concept. You know what concept I am going to teach you here. Here I wanted to say you, see, I am taking the same example, and in that example we have found the value of probability of being head equals to what? 1 by 2, and probability of tail equals to what? 1 by 2. Now see how this came. Again you go to first video, you can understand. So now if I will say I am doing one thing, I am adding both the probability. And what I am doing, I am adding probability of being head plus probability of being tail equals to what? 1 by 2 plus 1 by 2. Probability head equals to 1 by 2, probability of tail equals to 1 by 2. So how much? 2, 1 plus 1 equals to 2 by 2 equals to 1. Right? So you can see here, on adding the probability of all the possible outcomes, what is the, if I will toss a coin, what is the possible outcomes? Either it will be head or either it will be tail. So if I am adding the probability of all the possible outcomes, it is coming as 1. That means you can say that if I will write probability of head plus probability of tail equals to 1, if I will write this one, is there any confusion? I have found like probability of head plus probability of tail equals to 1. So same thing I have written here. No confusion. Now if I will write probability of head equals to 1 minus probability of tail, what I have done, I have taken this probability of tail in right hand side. So probability of head equals to 1 minus probability of tail. Any confusion till here? No confusion. Now this is, you have to understand. I am saying that if I will read from the statement, I can say that probability of getting head equals to 1 minus probability of getting tail. Or if I will verify from here, then probability of head equals to what? 1 by 2. Probability of tail equals to what? 1 by 2. Or if I will find probability of tail equals to 1 by 2, right? So 1 minus 1 by 2 equals to what? 1 minus 1 by 2 equals to 1 by 2. So you can see that when I am subtracting 1 minus 1 by 2, 1 minus probability of being a t, it is coming as probability of head. So that means if an event is happening, okay, you are finding the probability of an event, and if you want to find the probability of another event, that should be linked with that part. See, one event is getting head, another event is getting tail. So if you are finding the probability of getting head, you found like 1 by 2. Then getting probability of getting a tail, and if I have only 2 event, you can directly, what you can do, total probability count, maximum count is 1. So you can subtract the value of this probability from the 1, you will get another probability. What I am saying, if you have 2 event like getting head and getting tail, if you have found the probability of getting head by the method, by the formula, whatever the formula you are using, if you have found the probability of getting head, then you do not have to find the probability of getting tail by using the formula. Instead, you are knowing that only there is 2 event. One event I have already found 1 by 2. So another event probability will be total value, that is 1 minus present value 1 by 2. In another question, this will not be 1 by 2, it will be something else. That I will show you in another question. So this formula you have to remember. Probability of one event equals to 1 minus probability of another event. Probability of one event equals to 1 minus probability of another event. Here 2 events are head and tail, but in another question, event will not be head and tail. In the ball question, red ball, blue ball, something else will come, right? So you can write these 2 points. Fine. So one statement we can say from the formula, from here pH plus pt equals to 1, right? So from this one I can say one statement, the sum of probability of all the elementary event of an experiment is 1. This was an elementary event. Why? Because the value was 1 by 2, elementary event. So sum of all the probability of an elementary event equals to what? 1, right? So next we will see, if you remember the second question. Fine. So now what I will do, I have made the probability in the terms of head and tail. Now I will discuss this probability in terms of event, a normal formula. This is head and tail, but in the other question you will not get head and tail. So what should be the normal formula? Okay, so I will say I have an event E, right? So I have an event E, and this event means getting the value something else. I will take one example to explain. The dice example, right? The dice example. In the dice example, the question where, if you repeat the question again, the question was like, suppose we are throwing a dice once. So again I am writing the same question. I am throwing a dice once. So what could be the value? 1, 2, 3, 4, 5, 6, right? What is the probability of getting a number greater than 4? What is the probability of getting a value greater than 4? So this is the value, right? This side. So what is the value? Probability of getting a value greater than 4 equals to 2 by total 6. So I can say 1 by 3. Now another question is, what is the probability of getting a number less or equal to 4? Second part was, what is the probability of getting a number less than or equals to 4? So here less than or equals to 4 means how much? 4. So for that one the probability of event value 4 by 6. Fine. Now I will say one thing, 4 by 6 equals to 2 by 3, right? 2 by 3, right? Now I will say one thing, I am finding the second question answer in a different way. Second question is, what is the probability of getting a number less than or equals to 4? So what is the probability of getting a question, value less than or equals to 4? That means we can write it like, question is, see, try to understand the question how I am writing. What is the probability of getting a number less than or equals to 4 or equal to 4? This is the question given in your book, right? Now I am writing this question in a different way. I will say, the question is, what is the probability of getting a number less than 4? I will say, that means that means 1 minus, what is the probability of getting number greater than 4. See, the question given is, what is the probability of getting a number less than or equals to 4? What is the probability of getting a number less than or equals to 4? This one. In the simple answer you can find it by number of event is 4, sample space is 6, 4 by 6. But I wanted to solve it in a different way. I am saying this number in a different way. This question means, if you write this question in this term, this is also correct. That means 1 minus, what is the probability of getting number greater than 4? 1 minus, this is the probability of getting the number greater than 4, right? 5 and 6. So if I will subtract the value of getting a value greater than 4 from the 1, then you will get the value of this one. So what I will do, 1 minus, what is the probability of getting a value greater than 4? That was your first question. What is the value? 1 by 3. 1 by 3. What is this? 3 minus 1 by 3. 2 by 3. If you can see this answer, this is 2 by 3, this is 2 by 3. Both is same. So what I have done, I have retained the statement, whatever the statement given in the question in the another way. And that way is very efficient if you solve a bigger questions. Because here is only 4 numbers just beside, so you have counted. If I will say, let us say I will give a number like 1, 2, 3, 4, 5, 6, something, 10, 7, 8, 9, 10. Now question will be, what is the probability of getting number greater than 8? Probability of getting a number greater than 8 equals to what? 2 by 10, right? 1 by 5. But I will ask the question, what is the probability of getting a number less than equals to 8? Probability of getting a number less than equals to 8. So in that case, what you will do? In the normal way of solving the question is, you will go and read this one, count 1, 2, 3, 4, 5, 6, 7, 8. So I will say that 8 by 10. But if I will solve this question in this way, then we can say that 1 minus getting a probability of greater than 8, right? Or 1 minus 1 by 5. What is that? 5 minus 1 by 5. That is 4 by 5. If you solve this question, this is also 4 by 5. So it is equal, right? So that means if you have got one probability, another probability you do not have to find, just subtract the value from the total value, that is 1. 1 minus the value of this probability, you will get another probability. It's easy and you have to use this concept. Okay, so that is what you have to remember one line. If I will say for this statement, I will say one event is E, right? Then probability of an event E equals to 1 minus probability of an event complement. Okay, fine. I will I will explain in this way. Let me tell you. Let me tell you in this way, right? It is a better understanding. So if you have an event E, then you can say that probability of an event equals to something. You got something, right? Event is E, then you can write the probability as PE. But I will say the another event. What is another event? So another event we can say as another event equals to the event which is not an event E. If I will say one event is head, another event is tail. So another event is tail. If I will say one event is head, another event is tail. So another event is tail. Can I write this like not head? I am writing tail equals to not an head. Of course, if it is tail, that means it is not an head. So I am just writing another way. One event is head, another event is tail. So I am writing this event as in the terms of not head, right? So here, if one event is P, if one event is what? P of E, and another event, then another event we can say as probability of not of E. One event is probability of event. One of event is E, then another event will be not of E. One event is head, then another event is tail, and tail I am writing as not of head. So you can just see it is not, new word is came as not, and head is head. So I will just using the same concept. Probability of an event is E, another event will be not of E, right? So you have understood one line, that probability of an event plus probability of not an event equals to complete probability. What is the complete probability? Total probability is how much? 1. So this concept you have to remember. Probability of event E plus probability of not an event E equals to 1. Many questions will be solved by this formula. So I will write this formula in another way. So what I said, probability of event E plus probability of not an event E equals to 1. Or if you remember, if you have studied something called complement in the earlier class also, then you can write probability of event E plus probability of not an event. We are writing like the bar. Not is written by the same this line bar. So PE plus PE bar equals to 1. This is the question you can get in your objective exam also. Probability of event E plus probability of not an event E. This one we will read it as probability of event E plus probability of not an event E equals to 1. Or probability of event E equals to 1 minus probability of not an event. Both you can write it down and understand, and remember this, both is important, right? So this event is called this event PE bar, right? This event is called complementary of this event. P bar, it is an complementary event. It is a complement. PE bar is a complement of PE. So E bar and E bar is a complementary event, right? E and E bar. E is complement to E bar and E is complement to E bar and E bar is complement to E. Both is complement to each other, right? So you can get a question, what is the meaning of complementary event? Okay, you can get a question, what is the formula? PE plus PE bar equals to, you can get a question, PE equals to what? 1 minus PE bar. Okay, so these all things you can write it on completely, questions can be asked. Fine. Okay, now I will give some question and then we'll understand two more concepts, impossible event and sure event. So first we'll see the question and then we'll describe. The question is, in the same dice, I am throwing a dice. What is the probability of getting a number 8 in a single throw of a dice? Question is, I am throwing a dice. Then first question is probability of getting number 8 in a single throw of a die. Single throw of a die. Question is saying that, see, I am throwing a dice. So if I will throw a dice, what should be the possible outcomes? Possible outcomes will be 1, 2, 3, 4, 5, 6. This is the only possible outcomes for a dice. एक छकड़ी में 6 ही वैल्यू होते हैं तो हमको 1, 2, 3, 4, 5, 6 ही आएगा, उससे ज़्यादा नहीं आ सकता. Now the question is probability of getting number 8 in a single throw of a dice. Probability of getting number 8. Are you able to see number 8 here? So let me go by the process. I will say number of sample space equals to what? 1, 2, 3, 4, 5, 6. Number of event. Number of event. What is the event? Event is getting number 8. We are not seeing number 8 here anywhere. So I can say that number of getting event equals to 0. Right? Because I am not seeing number 8 here. It is not possible. It is not possible that 8 you will get in the throwing of a dice. So number of event equals to 0. So probability equals to what? Probability equals event equals to 0 by 6 equals to 0. So you can see that here the probability equals to 0. Okay, you just keep it in mind. I am giving another question and then we'll describe what is the meaning of 0 and what is the meaning of another value. So another question is, what is the probability of getting a number less than 7 in a single throw of a dice? Probability of getting a number less than 7. Okay, so you can say now, here again the number of sample equals to what? 6. Number of event equals to what? Question is, the event is what? Getting number less than 7. You can say here, you see and just say number less than 7 is how much? This is also less than 7, 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 this is less than 7. So that means how many count are there? 1, 2, 3, 4, 5, 6. Total number of event equals to 6. So you can see that question is less than 7, that means all the value came as an event. So if I give a probability of the event equals to 6 by 6 equals to 1. Probability of the value is 1 when the question is number less than 7. Probability value is 0 when the question is number getting the 8. So this value, if you go by the value, you can see that 0 is the minimum value. A probability will have a 0 as a minimum value and 1 will have a maximum value. Here, here in the dice, it is not possible that you will get a 7, right? So less than 7 means all the value came. So if all the value, whatever the possible value, sample space is there, and whatever the possible value, both are equal. That means this value means numerator value, this value should never be greater than the denominator value. Okay, numerator value should never be greater than denominator value. So what is the maximum value of numerator possible? That is equal to the denominator. What is the denominator? Number of samples is equal to 6. So that means this is the maximum probability possible. This is the minimum probability possible. So if in any event, if the any event what you are trying to search is not exist, you will get a 0 probability. Here the event is getting number 8, that is not exist here. So probability is 0. This probability is called impossible event. This impossible probability and this event is called, this event getting number 8 is called impossible event. And if the probability value is 1, that means it is a sure event. Sure event means that is pakka. If I will say, I am playing the Ludo, I will say that you will get a value number less than 7. That means you will be getting 6. So that is pakka. I am going to get something. That is a sure value. Sure value means 1 and impossible value means 0. So this is a impossible event and this is a sure event. Right? Sure event means when the probability value is 1, that means this is called the event for which the probability value is 1 is called sure event. The event for which probability value is 0 is called impossible event. This is a simple example and simple definition. Okay? You can write it there. Okay? So by this one, by seeing this value and this value, you can write one particular statement. The probability of an event less than or equals to greater than equals to. Probability of event cannot be less than 0. Probability of event cannot be greater than 1. So this is, you have to remember. This is, remember. Okay, you will get so many questions. Questions will be which of the following is a probability, which is not a valid probability. So always you have to keep in mind the probability of an event always will be less than or greater than or equals to 0 and less than or equals to 1. See, equals to is here. 0 is also possible, 1 is also possible, but the value will be under 0. So if I will say 15%, is this the probability? No. If I will say 2 by 3, is this the probability? Yes, because denominator is greater than numerator, so you will get some value between 0 and 1. I will say 1.5, is this the probability? No, because it is greater than 1. So this thing you have to remember, you will get some questions like that. Okay? Fine. So this whole concept is what I have said, if you have not written. Now you will have a very interesting concept of playing card. So that you have to see seriously. So what I have written there, I have written probability of an event less than equals to, greater than equals to 0, less than equals to 1. This one. Right. Now we will see another thing which is very interesting is playing card concept. What I will do, I am marking here. Why I am doing this one? Because I will give some concept of playing card here, and then I will solve some question on playing card in this side using the concept. You will see that how easy the questions can be solved. Okay. Okay, fine. Playing card concept. If any one of you is knowing the playing card in Hindi we can say tas. Okay, so if any one of you knowing or playing the tas, he might understand this particular subject, this particular content easily. But who is not understanding, for them also I have planned in such a way so that it will be very easy. Okay, so first thing, whenever you will be working on the playing card question, some word you will face. What all word will be there? Whatever the word will, some word will be there. Okay, you will get confused. What is the meaning of this word? So first I will let you explain the words, and then I will give the proper diagram. So you will see something called deck of playing card. First thing will coming here as. First thing it will come as. Okay. Deck. D-E-C-K. Deck of playing card. Right. First word you will see deck of playing card. I will say deck is very simple. Deck means packet. I have this playing card. Okay, just see this one. This is the playing card. Okay, so you can see this is a packet, right? So whenever you will go to any shop and you will say that give the playing card, then he will give this type of packet. So in this packet means there is something inside, right? So in this packet there is some number of cards are there which is rectangular in shape. This packet consisting of some number of cards. What many number of cards, that I will tell you, but some number of cards are there inside this packet. And deck of card means this is the card, and I am just taking it out. Okay, so see, this is called a deck of card. So this total card is 52. Okay, so deck of card, if some questions will come with the word like in the deck of card, then what you will understand, that means from the 52 cards. So deck of card, playing card means 52 cards. So whatever I have mentioned here, I will writing here. So here it is deck of card 52. 52 is a deck of card. Deck of card means this is the deck of card. How many cards are there? 52. Next point you will listen something called shuffling. Okay, shuffling means in Hindi mila dete hain. This is shuffling. Okay, I am shuffling this one. Shuffling means you are not understanding which card is going at which place. I am just shuffling this one. Okay, so shuffling will be the second word. S-H-U-F-F-L-I-N-G, shuffling. Okay, so now I am just I have mixed it, right? Let me do one thing. I have planned for something else, but I should not have mixed it. But anyway, see, because I have done the shuffle, so whatever the plan I have put it in a series, it is get mixed. So now I have to work on this again. Okay, fine. Okay, it will not take much time. Noises. So you have understood the meaning of shuffling, right? When you will shuffle, then you will feel like all the card is mixed. Okay, so I have segregated the card, right? Now out of these 52 cards, you will feel like there is only two types of card is present. Just see the color of this card. What is the color? Don't go by the design. What is the color? Color is red, right? Color is red. If you go by this one, what is the color? Color is red. Fine, I am keeping this one. I am going by this card. What is the color? Don't go by design, just see color. What is the color? Color is black. What is the color? Color is black. So I have these many cards. I have 52 cards, and these 52 cards is divided into which color? Okay, it is divided into red color and black color. Red color, black color. Because this is a 52 card and it is equally divided. No, it is equally divided in two color, red and black. So in the red, how many number of the card will be possible? 52 by 2, 26. In the black, how many cards will be possible? 26. Fine. So we can understood now, like 52 and 52 cards is there in the red, in the black. Now we'll come again to next point. Next point is I am taking the red card. This is also a red, this is also a red. So I am just counting one deck. See here, first of all, in the red card, what is this design? This is one design, right? Diamond, you can say diamond. In the red card, another design is this one, right? So I am making the design for both. In the red card, there is two designs. One design is this one. One design is this one. Okay, fine. In the black card, see the design. This is one design. This is one design. Fine. So in the black card, we have two design. One design is right, and another design is this one. Right? Just keep it like that. Don't go by my design and photo. I do not have much experience in designing a photo and all. So this is four different design are there. So what is the name of this design? So each have a different names. In Hindi we will say many things, but in English you have to understand, because you will get a question on English. Okay, you will get a question in English word. So this is called diamond. What is the name? This name is diamond. This is heart. This is clubs. This is spades. 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 So see, all the designs have a different name. Now, number wise, 26 is there in the red. Red is divided into two parts. So how much number will be there for diamond? For the diamond design, number will be 26 by 26 by 2, 13. For heart, how much number will be? 26 by 2, 13. Similarly, for black, gloves will be equals to 13 and spades equals to 13. Right? Everything is 13, 13, 13. If you will feel like I am just calculating, just take a card. I am taking this one. This is what? This is your spades. How many cards I am counting in front of you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means similarly for all the other cards it will be 13. Clearly, everything is clear. Deck have 52 cards divided into two color, 26, 26, red and black. Red has two design. This is called diamond having 13 card, heart having 13 card, black has two design, club having 13 card, spades having 13 card. Till now everything is fine. Now we'll go to another concept. If I am taking the example of this one, I am taking the example of this diamond, this one. Okay. If you will go with the card, you can see two type of card. This is called, see, some face is there, right? Some design, some face is there. This is some face is there, some face is there. So this 3 is called a face card. You can see this is the only 3 card having the face. If I will go to these cards, is there any face? It is not, there is no face, right? There is no face. There is no face. So that means 3 card is having the face. Rest, because there is a 13 card, so 3 card is having face. Rest card is what? Number. That means this is divided into which type of card? Number card and face card. So this is number card and face card. Right? Face card. How many face card was there in the face card? So that means everyone will be divided into number card and face card. So this will be also will be having number card and face card. I am saying no, number card as NC, face card as FC because of the space pull-on. Okay. So number card NC, space card is number card is NC, face card is FC. Here also it will be number card, face card. It will be number card, face card. So how many numbered cards were there? How many face card was there? Face card was 3. Number card was 8 to 10. Why I am saying A? Just go again and see. See. In this one, everything is numbered. 2, 3, 4, 5, 6, 7, 8, 9, 10. But there is A. So this is not a face card, it is a number card, but it is considered as, because it is not a number, so in the when you will play, you will say this as a card. So this is considered as a number card only. So we'll put it as a card. What is the A full form is? A card, ACE. A means ACE. ACE. And in the face card, okay, in the face card, there is 3 things written: K, Q, J. J, Q, K. So which all cards are there in the face? J, Q, K. So J means Jack. Q means Queen. K means King. So you can say that number card is 10, face card is 3. Here also, number card will be A to 10, face card will be 3. Okay. Here also, number card will be A to 10, face card will be 3. Here also, number of card will be A to 10, face card will be 3. And the face card will be, that means one A is present here, one A is present here, one A is present here, one is present here, right? Jack, here also the same face card will be there. J, Q, K. J, Q, K. J, Q, K. This is the distribution. This is the whole playing card concept. This is the distribution. Now if I will read one by one from the start, what I will say, in a packet, okay, in a deck of 52 cards, in a deck there is a 52 cards. Out of these 52 cards, it is divided into two colors. So always the playing card is divided into only two color, okay. One will be black, one will be red. Black will have 26 card, red will have 26 card because it is equally distributed. In the red we have two different designs. One is called diamond and heart. Another in the black is club and spades. In the diamond we'll have 13 card because this is equally distributed. 26 is divided into two parts, so 13 is there. And in the black, clubs is this is divided into two parts. Clubs is 13 and spades is 13. Now in the diamond design, this is the diamond design, we'll have 13 cards. So out of these 13 cards, 3 card will be a face card and 10 card will be a number card. So in the face card we'll have a J, Q, K called Jack, Queen, King, and number card will be A to 10, that is A is called ACE, A card, okay. And next will be 2 to 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. So similarly in the heart also one ACA will be there and 3, in that is J, Q, K will be there. Clubs also one ACA will be there, one J, Q, K will be there. Spades also ACA will be there, J, Q, K will be there. So that means in whole playing card, how many Jack will be there? 1, 2, 3, 4. In the playing card, how many Queen will be there? 1, 2, 3, 4. In the playing card, how many King will be there? 1, 2, 3, 4. Right? In a playing card, how many ACA will be there? 1, 2, 3, 4. Right? So this is the whole concept of playing card. So we'll now I will write some point that you have to write down and understand. Okay. I am writing point one by one. Okay, you can write it down. First point is total number of card equals to total number of card equals to 52. Second point, red color card equals to (26). Black color card equals to 26. Fourth point, total number of suits. Yeah, I forgot one point. These all 4 designs, diamond, heart, clubs and spades, is called suit. S-U-I-T, suit. So if some questions, many questions will find like some suits. Suite means whenever S-U-I-T, suite, okay? Suits are there, right? Suitcase we can say, no, right? The one suitcase we are keeping something, so from there suit is came, okay? Suit means the playing card in any of the 4 sets. Suit means sets. So these are the sets. One diamond is there, one heart, clubs and spades. So these are called the suit. So one suit is diamond, one suit is heart, one suit is club, one suit is spades. Okay. So total number of suit equal to total number of SUIT suit equals to 4. 1, 2, 3, 4. Fifth point. 4 different suits are 4 different suit equal to diamond, heart, club and spades, right? 6 point. Number of card in each suite. Number of card in each suite equals to number of card in each suite. How much? 13. In this suite also 13. In this suite also. In this suite also. In this suite also. So number of card in each suite equals to 13. Okay. Total number of face card. number of face card. How much face cards are there? Here 3, here 3, here 3, here 3. 3 into how much? Total number of face card in one suite. Let it break it in one suite. Equals to, in one suite total number of face card equals to 3. In one suite total number of face card equals to 3. 8. Total number of face card, name of the face card. Okay, so what is the name of the face card? Jack, Queen, King. Jack, Queen, King. Jack, Queen and King. Okay, 9th point. Total number of face card in a deck. Total number of face card in a deck equals to, in a deck means out of 52 cards, how many face cards are there? In one it is 3, in one suite it is 3, we have 4 suites, so 3 into 4, right? 3 into 4 equals to 12. Okay, 10 point. Total number of jack. Total number of jack. In this one suite there is one jack, another suite also one jack, so there is 4 suite, so 1 into 4. 1 into 4 equals to 4 jack. So 11 point. Total number of queen equals to 1 into 4 equals to 4. 12 point. Total number of king equals to 1 into 4 equals to 4. Okay, so now total number of ace. 13 point. Total number of ace equals to 1 into, see, eka is here also, eka is here also, in all the 4 suites one eka is there, so 1 into 4 equals to 4. Total number of jack, okay, equals to 4 in a deck. Okay, so when I am saying total number of jack, that means I am in a deck I am asking, right? So 14 point. Total number of jack in one suite is how much? Total number of jack in one suite equals to 1, but total number of jack in a deck equals to 4. So total number of jack equals to 1 into 4. Total number of queen equals to 1. These all things is in a deck. In a deck. Okay. Total number of jack in a deck equals to 4. Total number of queen in a deck equals to 4. Total number of king in a deck. In a deck, total number of king equals to 1, 2, 3, 4. In a deck, total number of queen equals to 1, 2, 3, 4. Okay, so that this diagram you remember, everything will be finished. Okay. 14th point. Total number of ace in a deck. Okay. So this is the total number of ace in a deck is 4. Now total number of ace in a suite. Total number of ace in a suite. एक suite में कितना एका है? Only एक एका है. Equals to 1. 15 point. Total number of queen, comma, king, comma, jack in a suite equals to 1. I will go and I will read it again, okay, so that you can, whoever is not able to see this, what I have written, when I will, read all these things, you can write it down. And this is the whole concept of the playing card. This concept is not for the 10th. This concept you will use in your life, in 11th, in 12th, in engineering, in medical, wherever in engineering exam preparation, if you remember this one, none of the questions will be, it is not like you will not able to solve any of the question. All the question you will be able to solve once you will understand this particular concept. Okay, this is the only concept. This is a very high level and very basic concept I have given. Okay, so what is that? I am going and I am saying again. Okay, playing card concept. This is the deck of card having 52 cards. Total number of card equals to 52. Red color card 26. Black color card 26. Total number of suit equals to 1, 2, 3, 4. 4 different suit name are diamond, heart, club and spades. Diamond, heart, club and spades. Okay. Number of card in each suite 13, 13, 13, 13. In each suite there is 13 card. Total number of face card in one suite equals to 3. Total number of face card in one suite JQK is 3. Right. Name of the face card equals to Jack, Queen, King. Total number of face card in a deck equals to 3 into 4. In a deck, total number of face card in one suite that is 3. So in a total deck, so total deck is, if we go by this one, then total number of face card in the deck equals 3 into 4 equals to 12. Okay, total number of jack equals to 1 is here. Total number of jack in a deck. In a deck, total number of jack equals to 1, 2, 3, 4. Similarly, king, queen, ace is 1 into 4 in a deck. If you talk from the suite perspective, total number of ace in a suite. In a suite, total number of ace equals to 1. In a suite, total number of king, queen is equal to 1, 1, 1. Okay, this is the whole concept. So you just write it down. Next class, I will take questions. Okay, thank you so much.